Hi students, welcome you to my class, and I know you are looking forward to the another concept, and here I am going to discuss about your favorite concept is that cylindrical capacitor, which you want to know, and all of you know the capacitor and capacitance. Okay, so let us describe about the explain. I am discuss about the cylindrical capacitor and its capacitance. So let us start today. Let us start. Cylindrical capacitor. Cylindrical capacitor. Cylindrical capacitors. Cylindrical capacitor. Okay. Cylindrical capacitor. And cylindrical capacitor is a two coaxial cylinder. Two coaxial cylinder having a common axis and having two different radius. One is the inner radius, outer is the outer radius. Okay. Let us carefully see. Fine. And this is the axis of the cylinder. This is the axis of the cylinder, and this is the length of the cylinder is capital L, and inner radius is small r, and outer radius is, so inner radius you take small a. Inner radius take small a. Okay, take inner radius is small a. Inner radius is small a. This radius is small a, and outer radius is b, and length of the cylinder is L. Okay, understand? So it is consist of two, because of the same axis, two cylinder having same axis, that's why it is known as coaxial cylinder. Let us take, so it consists of two coaxial cylinder. Two coaxial cylinders having radii A and B respectively, okay, and length of the cylinder L is the length of the capacitor, length of the capacitor, and here L is very large than the radius, because A or B. Why? Because the space between the two cylinder is very less. Okay, there is just very little gap between the two coaxial cylinder. That's why, due to small space. Okay, and the two cylindrical cell having the charges. Two cylindrical cells having carry charge minus q and plus q respectively. Minus q and plus q, right? Okay, so it consists of two coaxial cylinders having radii A and B respectively, and capital A is the length of the capacitor. The length is much greater than the radii A or B due to small gap. The two cells carrying the charges minus Q and plus Q. Okay, here the two cylindrical cells having uniform, we have taken uniform linear charge density. Here the uniform linear charge is distributed uniformly throughout the cylinder. That's why we take here two cylinders having two cylinders having uniform linear charge density. Plus minus lambda. Okay, and the electric field is only due to the inner cylinder. And we have to find out electric field. Find out the electric field. At any point in the space between the cylinder. In the space between the cylinder. Okay, understand? So let us consider any point P in the cylinder between the space of the two cylinders. Let P be a point, and we have to find out the electric field at any point between the space in the cylinder. Okay, let P be a point. Let P be a point. Any point in the space between the cylinder at distance r from the axis. Okay, and you can imagine a Gaussian surface. Gaussian surface passes to the point P, and here the charge inner cylinder carry negative charge and outer surface will carry positive charge. Okay, so the electric field at any point. So what is the electric flux at the point P? Let P be any point. Any point at distance r. From the axis. Okay, so what is the electric flux? The electric flux. So it behaves like an Gaussian surface. So through the point we can imagine a Gaussian surface we can imagine a Gaussian surface through the point P. Okay, understand? Okay, so what is the electric field, electric flux at the point P? Let us find out the electric flux. The electric flux at the point P. What is the electric flux at the point P? Electric flux at the point P is phi is equal to Q divided by epsilon 0, or the product of the charge into area, where the electric flux, whole flux charge is distributed through the area. So Q by, that is equal to E into area, is 2 pi RL. Okay, let P be any point at a distance r from the axis. We can imagine a Gaussian surface through the point P, and the electric flux at the point P is phi is equal to Q by epsilon 0, and all of you know, and is equal to electric field, product of electric field and area, where E into 2 pi RL, that is equal to 2 pi RL E is equal to Q by epsilon 0, right? Okay, so and you know linear charge density, we know linear charge density what? Linear charge density is charge by total length, yes or no? And charge is equal to L into lambda, yes or no? By lambda L. Okay, so in these places can you put the values of lambda L? Okay, and let us see. So in place of Q can write lambda L by epsilon 0 is equal to, what is that? 2 pi R L E. And you see L can be cancelled. We can cancel L and L here. Okay, after cancellation, we'll get electric field, the value of E, that implies E is equal to, E the value will be, what is that value, tell me? Lambda divided by 2 pi epsilon 0 and R. This is the electric field E at the point P. Okay, understand? Now okay, acha. Now the potential difference, hence the potential difference between the two cylinders is equal to negative value of integration of E dot dr and A and B. Since the E and dr are always act in opposite direction. Opposite direction, all of you know. Okay, so integration of integration of AB EDR and integration of A to B. E value, what is the value of B? Lambda by 2 pi epsilon 0 r dr, right? Okay, understood? This is the potential difference V. This value is V. Potential difference V value. Okay. Then the potential difference V is equal to integration of A to B lambda by 2 pi epsilon 0 r dr. That implies lambda is a constant, 2 pi epsilon 0 r constant can be taken out, and AB 1 by r dr. And all of you know the integration of 1 by x, whatever, log x. Yes or no? Okay. So let us see here. Here we see that is called lambda by 2 pi epsilon 0. So it is log r A to B. That is the potential difference B. Okay. So B is equal to lambda by 2 pi epsilon 0 into log B minus log A. And that is equal to lambda by 2 pi epsilon 0 log B by A, B upon A. Okay, and this is the potential difference between the two cylindrical cells. B by A, right? Okay, understand? Okay, then the total charge, you have to find out the total charge. Total charge on each on each surface of the cylinder. Total charge. What is the total charge? The total charge okay, the total charge on each cylinder Q is equal to what happened? Total charge is L into lambda. Yes or no? And we know C is equal to Q by capacitance is C by V. Q will L by lambda, and V value we got what? Lambda by 2 pi epsilon 0 and log B by A, right? So what will happen, you see? Now you see lambda can be cancelled. We can cancel lambda. Okay, then we shall get what? capacitance of the cylinder is equal to this 2 pi epsilon 0 will be, so it will be 2 pi epsilon 0 length of the cylinder divided by log B upon A, and this is the capacitance. This is the capacitance of the two cylindrical capacitor. This is the capacitance of cylindrical capacitor. Cylindrical capacitor. Understand or not? Okay. And we know log B by A can be written also what? Natural logarithm, we can common logarithm 2.303 log B by A to the base A. B by A to the base what? 10. Base 10. Okay? Understand? Okay? So right here, so did you understand the desired information and what is the capacitance of cylindrical capacitor? So all of you practice this, okay, and will apply how to use this expression to find the capacitor of the cylindrical capacitor, okay, in solving problem. Okay, thank you all of you with this. See you next. Okay, thank you.